Hello everyone, this is Mathematics lesson for grade 8. This program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm teacher Mamu. Today we will see some points on Unit 8, which is about a pyramid. But before I proceed to the present lesson, I want to remind you some of the points that we have seen in the previous lesson. Well, if you were attending my class, in our previous lesson, we have discussed about cylinders, the properties of cylinders, and the measurements associated with cylinder, right? So just to summarize the points, I will use a single example, what we have seen in the previous lesson. Well, in cylinder, we have seen the lateral surface area of a cylinder is given by the formula 2 pi r L. Okay, this is the formula for 2 pi r L. This is the formula for a lateral surface area of a cylinder, where this r is the radius of the base, the circular base, and L, or you can say H, is the notation that we use to represent the height. Okay, so this is the formula for a lateral surface area, and the total surface area of a cylinder is given by the sum of the lateral surface area plus 2 times area of the bases. Okay, so whenever we say total surface area, we are assuming the area of the curved part and the area of the two bases. That's why we write the total surface area as the sum of the lateral surface area plus 2 times area of the base. Okay, the third formula that we've seen in the previous lesson was about the volume of a cylinder. Okay, so the volume of a cylinder is given by the formula as the product of base times height. Okay, so area of the base, the product of area of the base times h gives us the volume of a cylinder. Okay, since the base is circular, in place of AB you can you can substitute area of a circle. As you all know, area of a circle is given by the formula pi r square, where r is the radius of this circle. So this cylinder, the volume of cylinder is given by pi r square times h. Okay, these three are the formulas that we have seen in our previous lesson. Now let's take a single example to see how this formula can be applied. Okay, so let's take this example. If the radius of a circular cylinder is 4 centimeter and its height is say 8 centimeter, find the lateral and total surface area and the volume of the cylinder. So in this example, what's given, there is a circular cylinder whose radius is 4 centimeter and its height is 8 centimeter. Okay, so based on this, you are asked to find the lateral the total surface area, and the volume of the cylinder. Okay, so to calculate these three things, the only thing that we need to apply is their formulas. Okay, so you need to pick the first formula to calculate the lateral surface area. So our lateral surface area in this case becomes okay. The third one is finding the volume of the cylinder. Okay, so to find the volume of the cylinder, we need to properly apply the formula that we used here, pi r squared times h. So the volume of the cylinder becomes pi times r is 4 centimeter square times the height, which is 8 centimeter. Okay, so the square of 4 is 16, okay, and its unit becomes centimeter square. So this becomes pi times 16 centimeter square times 8 centimeter. Okay, so you can take the product of 16 and 8, it becomes 128. Okay, so you have also pi, so the whole this product becomes 128 times pi centimeter cube. This is the required volume. Okay, so this is how we calculate the different measurements associated with a cylinder. Okay, so now I believe you are familiar on calculating the lateral surface area of a cylinder, the total surface area, and the volumes too. Okay, so these are the things that we have seen in the previous lesson. Today we proceed to the next solid figure, which is about pyramid. Okay, so let's proceed to the present lesson. So far we have seen two different solid figures which are about prism and cylinder, and there are some common properties in prism and cylinder. Their common property is having two bases. Okay, so the next two solid figures have also something in common. This is a cone and this is a pyramid. What makes these two solid figures similar? These two solid figures have one vertex which is not lying on the bases, and they do have a single base. Due to this, our measurement will be different from what we have seen in the previous case. Okay, so today we will be focusing only on the pyramid and the terminologies associated with pyramid. Okay, so here we have different terminologies in pyramid. As you can see here, this is a pyramid with a square base, and this point P, this point, so as you can see here, we have different terminologies. This point P is a point which is not lying on the base, and we call it a vertex. And this edge, PD, is edge. In fact, we have different edges. So to mention the different edges in this solid figure, one of the edge is PPD, okay? And you can specifically call this a lateral edge because there is a difference between base edge and lateral edge. So, so this is one of the lateral edge. We call it edge simply. And PC is also another edge. PC, okay? This segment is another edge. The third one is PB. Okay, this segment is another edge, okay, PB, and we have one more edge which is PA. Okay, so in this specific solid figure, we have 4 edges, which is a lateral edge, and you have also here different base edges. Okay, BC is a base edge. Okay, you can call it base edge. Okay, BC is one of the base edge. The other one is this CD or DC is another base edge. The third one is AD, okay, AD, and the fourth one is this segment, AB or BA. Okay, so we have 4 base edge, 4 lateral edge. The other is a slant head. Here in pyramid, there are 2 heads, slant heads and the altitude or the vertical heads. Okay, so we have this PQ as a slant head. Okay, this is called a slant head. You can have different slant head on different faces. Okay, but the altitude of the pyramid is a line segment joining the point P to the center of the base. Okay, so PO or OP is a vertical head, call it altitude. Okay, so whenever we say altitude, we mean to say that the vertical height of the pyramid. Okay, so these are the terminologies that we usually use in the discussion of a solid figure, particularly in pyramid. Okay, now let's see the measurements. Okay, like we did for the previous 2 solid figures, here we will derive a formula for a lateral surface area, the total surface area, and the volume of the pyramid. Okay, this is roughly the pyramid. So now let's see how we can calculate the surface area. Okay, our surface areas are, so we have 2 areas, the lateral surface area and the total surface area. Okay, we will see each of them separately. Then we calculate the volume of a pyramid. Here, lateral surface area means the area of each faces. So as you can see here, the faces, okay, you can say this is A, B, C, this vertex is say D, and this is E. Okay, all the faces of these solid figures are triangular. So we need to add the sum of the area of each faces that gives us the lateral surface area of the cylinder. Now here, as you can see, there is a line joining the vertex to one of the base edge, forming 90 degree, and this is considered as a slant head. Okay, don't forget the vertical height is a line joining the point A to the point on the center of the base. Okay, so this L is roughly the slant height. We will use this L to calculate the area of each faces. Now the lateral surface area is the sum of the area of the front part. Okay, area of triangle ABC. Okay, I take this part, and you have also another triangle on the side part, ADC. Okay, you can add this triangle, the area of triangle ADC, plus we have another face, lateral face, AED. Okay, AED. Okay, area of triangle AED, and the other side AEB. Okay, so you add all these areas. So triangle, area of triangle, ADC, AED, triangle AED plus area of triangle AEB. Triangle AEB. So here the sum of all these areas, triangular areas, will give us the lateral surface area. Now we will represent each of these areas in terms of the lateral side, I mean in terms of the slant height and the bases. So as you can see here, the area of this triangle ABC is half of the product of AB times the slant height. Okay, so in place of triangle area of triangle ABC, you can replace half of BC times the slant height. Okay, so you can write L plus the area of the next triangle, triangle ADC. Okay, the area of this triangle ADC is half of the base DC, half of the base DC times for this triangle part, you can construct a slant height like we did for the front part. Okay, so you can roughly construct a slant height so that you can calculate the area of the triangle ADC. So the area of triangle ADC is half of DC times the slant height, plus we keep doing the same thing. We take area of the back side, area of triangle AED, which is the product of 1/2 times ED, 1/2 times ED times the slant height. Where do we obtain this slant height? By constructing a line segment joining from A to ED in such a way that ED, I mean A some point F, you can call it, and that AF can be a slant height. Okay, so lastly we do have one more areas, which is about triangle AEB, this part. Okay, triangle AEB is half of the base EB, the base EB times the slant height. In all these cases, our slant heights are the same. Now, there is something common in all these four terms, 1/2 times L. Okay, if you factor out 1/2 and L, we will have, in the bracket, we will have BC plus DC plus EB, ED plus EB. So whenever you factor out half and L from each of these terms, the remaining thing in the bracket will be BC plus DC plus EB plus ED plus EB. Okay, now you need to consider the whole this expression. BC is this part, okay? DC is this part. ED is this one, okay, this side, and EB is this one. Okay, now the sum of these segments means the sum of each side of the base. Okay, as you all know, the sum of all sides of any polygon is called a perimeter. So in place of this bigger expression, you can substitute the perimeter. So this formula becomes half of L times the perimeter. Okay, you can write in any order because multiplication is commutative. Therefore, our conclusion here is area of, the lateral surface area becomes half times perimeter times length, where this length is the slant height. Okay, you need to differentiate it. Whenever we have a pyramid, if you are asked to calculate the lateral surface area of any pyramid, you can take the perimeter of the base and the slant height, multiply it, then divide by 2. Okay, this is the formula that we use to calculate the lateral surface area of a pyramid. Okay, next we do have the total surface area. As you all know, the total surface area of any solid figure is the area of each lateral faces together with the bases. Okay, in this case we have only one base. Okay, so whenever we are calculating the total surface area of a pyramid, we take the sum of the lateral surface area plus area of the base. You shouldn't multiply area of the base by 2 because we don't have two bases. We use 2 times area of the bases for the previous two solid figures, for cylinder and for a prism. Okay, when you come to this pyramid, you need to add the lateral surface area plus area of a single base. Okay, so this is the formula we use to calculate the total surface area, and the volume of a pyramid. The volume of a pyramid is 1/3 of area of the base times h. I may not prove this thing. The proof of this part will be discussed whenever you join grade 10. Okay, for the time being you will take as it is. Okay, we don't prove it, but you need to take the volume of a pyramid is 1/3 of area of the base times height. Okay, so take this one and use it whenever there is question related to measurements in pyramid. Okay, so let's see now examples related to measurements of a pyramid. Okay, now let's see the first example. Okay, here you can see there is a pyramid. Let me read what the example is saying. Find the lateral surface area, the total surface area, and the volume of a square pyramid given below. Okay, we can specifically name the pyramid depending on the nature of the bases. Okay, here we call it this pyramid a square pyramid because the base of this pyramid is a square. Okay, you can call it triangular pyramid if the base is triangular, rectangular pyramid if the base is rectangular. So the naming, the specific naming of any pyramid is dependent on the bases. Now here in this first example, we are asked to find the lateral surface area of this pyramid, the total surface area, and the volume. Okay, so to calculate all these three things, you need to remember the formula that we already derived, and we picked some formulas for volume. So let's start let's say the lateral surface area. So the lateral surface area, as I have said earlier, the lateral surface area of a pyramid is given by the formula half of the perimeter of the base times the slant height. Okay, here the sides on the base are given and the slant height is also given. So it's a matter of substitution. Now, what is the perimeter of the base? This is a square base. Okay, if this is 8, this is also 8. Okay, this is also 8 centimeter because in a square all sides are the same. So the perimeter of the base means the sum of all these sides. Okay, 8 centimeter plus 8 centimeter, let's put it here, half of 8 centimeter plus 8 centimeter, or you can make it 8 times 4. Okay, plus 8 centimeter plus 8 centimeter times the slant height, which is 10 centimeter. Okay, the sum of all this is 32, and half of 32 is 16. Okay, we multiply 16 centimeter by 10 centimeter, and this product gives us 160 centimeter square. Okay, this is the lateral surface area of the given pyramid. Next, we are asked the total surface area. Okay, the total surface area is the sum of the lateral surface area plus area of one of the base. We have only one base, area of the base. Okay, from the first we can take 160 centimeter square in place of AL. Okay, in place of lateral surface area you can take 160 centimeter square plus area of the base. Do you remember how we can calculate the area of a square? Well, the area of a square can be calculated by the product of the length times width. So since the length and width are the same, you can multiply 8 centimeter by 8 centimeter. Okay, so the result becomes 64 centimeter square. Okay, so this is 160 centimeter square plus 64 centimeter square. Okay, so the sum of this becomes 224 centimeter square. This is the total surface area of the given pyramid. And we are left with the volume. Okay, the volume of this pyramid is given by the formula. The volume of the pyramid is given by the formula 1/3 of area of the base times h. Now we have area of the base, which is 8 by 8 or 64 centimeter square. So 1/3 of 64 centimeter square times the height h. Here is the technique. We don't have h or the altitude of this pyramid. The only thing that we have here is the base, the sides of the base and the slant height, but we don't have the altitude of the pyramid. Remember, the altitude of a pyramid is a line joining the vertex and the center of the base. Okay, you can construct like this. Okay, it should form 90 degree. It should be perpendicular to the base. Then this h should be determined. We don't have this h. So to calculate this unknown side, which is the altitude of the pyramid, we need to be systematic and construct a triangle, which is a right angle triangle in this manner. Okay, you can connect this center of the base to this point, okay, the point where the slant height meets the bases. So this segment is 4, okay, 4 centimeter, because the whole this segment is 8. Now we have a right angle triangle. You can call it, say this is O and this is A. You can see that triangle VOA is a right angle triangle by construction. If it is a right angle triangle, we know that this slant height becomes a hypotenuse for triangle VOA. Okay, VA becomes the hypotenuse. If VA is the hypotenuse, we can apply Pythagoras theorem to determine the unknown side, h. So write h square plus 4 square is equal to 10 square. Okay, there is a unit for h, which will be in terms of centimeter. So this is 4 square, sorry. So h square plus 4 square is 10 square, means h square plus 16 is equals to 100. And take this number, h square becomes 100 minus 16, and this difference becomes 84. Therefore, h becomes a square root of 84. Okay, so this is the unit of this h is centimeter. Now we have the altitude of the pyramid, which is radical 84. So substitute here radical 84. Okay, so this becomes 1/3 times 64 centimeter square times radical 84 centimeter. Okay, so the volume of this pyramid becomes 64/3 times radical 84 centimeter cube. Okay, this is not the only way to represent this number. You can rewrite radical 84 in different ways, but this is not part of our discussion for today. So you can put the volume of a pyramid, in this case becomes 64 over 3 times radical 84 centimeter cube. Okay, this is how we calculate the different measurements in pyramid. Okay, for today I will add one more example, then we conclude our discussion. Okay, now again let's see the second example about pyramid. It says the altitude of a regular square pyramid is 12 centimeter. The altitude of this pyramid is given, which is 12 centimeter. If one edge of the base is 10 centimeter, then find the lateral surface area, the total surface area, and the volume of the pyramid. Well, so here we have everything. The side of the base is given, and the altitude of the pyramid is given. Okay, not everything is given. One more information is lacking to calculate the lateral surface area and the total surface area. That is the slant head. Okay, so here we have to calculate first the slant head, then after we proceed to the calculation on the lateral surface area. Come on, here this is 12. That means we can construct a line joining the center to the one of the point here. Okay, so whenever we construct this segment from the center of the base to the other side, we need to make our construction in such a way that the center and this point joins the base of the slant head. Okay, usually the slant heads are drawn from the vertex to one of the sides by forming 90 degree, right? So now this height is, call it h, it's 12, and this segment from this center to this point is half of the whole this segment, which is 5. Okay, 5 centimeter. We have 12, we have 5, and this part, to make it clear, let's write V, call it this O, and say this A. Okay, VA becomes the slant head, and if you consider triangle VOA, it becomes the hypotenuse for the triangle. Okay, say this is L, which is the slant head for one of the lateral face. Okay, so from triangle VOA, L becomes the hypotenuse, so that we can write L square is equal to 12 centimeter square plus 5 centimeter square. Okay, so this becomes L square is equal to 144 centimeter square plus 25 centimeter square. Okay, the sum of these two becomes 169 centimeter square. So L becomes square root of 169 centimeter square. Okay, 169 is a perfect square, so that you can take it out. So this becomes L is equals to 13 centimeter. Okay, now we can calculate the surface areas and the other things. Okay, so what is given? What is given here? The side is given, the height is given, okay, h is given, which is 12 centimeter, and the side you can call it x, which is 10 centimeter, and we have also the slant height is 13 centimeter. So now we can calculate the lateral surface area. The lateral surface area is half of the perimeter of the base times the slant height. Okay, now the perimeter of the base is, look, this is 10, this is 10, it's a square base, so 10 plus 10 plus 10 plus 10. Totally we have 4 times 10. Okay, so this becomes half of 4 times 10 centimeter times the slant height, which is 13 centimeter. Okay, so this is 40 centimeter. Half of 40 is 20. Multiply 20 centimeter square. This is not square. Okay, multiply 20 centimeter by 13 centimeter. The product of 20 and 13 is 260. So the whole unit becomes 260 centimeter square. Okay, this is the lateral surface area of the given pyramid. The next question is about the total surface area, which is the sum of the lateral surface area plus area of one of the base. In fact, we have only one base. So the lateral surface area is already obtained, which is 260 centimeter square plus area of the base. Since the base is a square, the area of this square becomes 10 centimeter times 10 centimeter. Okay, multiply this, the result is 100 centimeter square. Okay, this is 100 centimeter square, this is 260 centimeter square, so the whole this sum becomes 360 centimeter square. Okay, so this is the total surface area. So we are left with one more thing, which is about volume of a pyramid, and the volume of a pyramid is 1/3 of area of the base times h. Okay, area of the base is already obtained, which is 10 by 10. That means 100 centimeter square. So 1/3 of 100 centimeter square times the height of the pyramid, which is 12 centimeter. Okay, so 12 centimeter. Okay, now 100 times 12 is 1200, divided by 3, the result becomes 400. Okay, so the volume of this pyramid becomes 400 centimeter cube. Okay, so this is how we calculate the different measurements in pyramid. Okay, so in this lesson we have seen terminologies related to pyramid, and we have also discussed the different measurements associated with pyramid. This is all for today. I hope you enjoyed the lesson. Thank you for watching.